Hello everyone. In this video we are going to talk about bipartite graphs and matching in bipartite graphs. So first, what is a bipartite graph? So here in this slide we have an example of a bipartite graph. On the left we have people who have been represented as vertices, and on the right we have tasks which have also been represented as vertices. Now the links between people and vertices denote the tasks that a particular person is willing to do. For example, you can see that you, the vertex U, that is the person U, is willing to do task X. Hence there's an edge between U and X. Now this is how we model bipartite graphs. There is no link among the people and there is no link among the tasks, and edges only go from left to right in this particular graph. Next, let's look at matching in a bipartite graph. Now matching gives an assignment of people to tasks in this particular problem. So in this particular problem, we have 5 people, A, B, C, D, and E on the left. And there are 5 tasks, 1, 2, 3, 4, and 5 on the right. We want to match as many people to as many tasks as possible. But note that only one person can be matched to a particular task. Not 2 people cannot be matched to the same task. So here we have a particular matching. A is matched to task 1, C is matched to task 2, and D is matched to task 5. This is a matching, where some people have been matched to tasks. However, this is not a maximum matching. We can do better than this. For example, a better matching would be if D was matched to task 4 and E was matched to task 5. In that case, at least 4 of people have been matched to the tasks. So this particular example is an example of matching, but it's not maximum matching. So the problem that we're going to study in this video is how do we get maximum matching in a bipartite graph. To do that, what we are going to do is we are going to use the instance of network flow, and where the solution to the network flow problem can be used to find the solution to the bipartite matching. In this video, I'm not going to talk about network flow and the algorithms used to find the maximum flow, network flow in a graph, but what I'm going to talk about is how do you transform a bipartite graph into a general graph on which you can apply network flow, and the network flow would help you give the maximum matching in this bipartite graph. To do that, what you do is you take an instance of the maximum bipartite graph, and then you transform or reduce it to an instance of network flow. Now, how do we do that? Now, this is our particular graph that we have been talking about. First, what we do is we convert this undirected graph into a directed graph. Now, all the edges from the people to the tasks are now directed. In the previous case, it was undirected. Next, what we do is we add a source and a destination or a sink T. So the source is S and the destination or the sink is T. We add edges between S and all the people. And these are directed edges which go from the source to the people. And we also add directed edges from the tasks to the sink or the destination T. Now this is the particular graph that you're getting. Now once you get this particular graph, all that we have to do is first add weights of 1 to each of these links in this particular graph. So what we did is we started off with a bipartite graph, and we have now transformed it into this particular general graph in which each vertex has a weight of, each edge has a weight of 1. Now in this particular graph, if you find the maximum flow, then what we will have is we will find the maximum matching in the bipartite graph. As I mentioned, we will not talk about how to find the maximum network flow in a graph in this video. For that, please do watch another video in this playlist. But what I talked about here is how to convert a bipartite graph into a general graph on which you could apply the network flow problem. So just to recap, what we are given is a bipartite graph G. It's represented usually as A union B, where A is all the vertices on the left, B is all the vertices on the right, E is the set of directed edges that go from A to B. What we do is we add 2 new vertices, the source S and the sink T. We add an edge from S to every vertex in A. Note that this is a directed edge from S to A, and then we add an edge from every vertex in B to the sink T. We then make all the capacities or the weights of all these edges as 1. Now the goal is to solve the maximum network flow problem in this new graph G prime that we have created from this bipartite graph. Now the edges used in this maximum network flow will correspond to the largest possible matching. We'll talk about network flow in the next video. Thank you for watching. If you like this video, do subscribe to my channel.